Chemistry and space. This video will be about the states of matter and space.
Solids can hold their own shape and are hard to compress. The molecules are densely packed together because they have such high attraction. Liquids take the shape of the containers they're in, and these molecules are further apart and can move more freely, thus creating the change in shape. Gas has no fixed shape or volume and has lower densities than solids and liquids. The particles are spread far apart and barely interact with each other because they have such little attraction. Plasma is a form of matter that exists when atoms are in an excited state. Auroras are another form of plasma where atoms in the upper atmosphere are affected by particles coming in from outer space.
Our universe is composed of these states of matter. Plasma is one of the most common states of matter and makes up around 99% of the visible universe, such as stars. Planets such as Mercury, Venus, and Mars consist of solids like rock, minerals, and metals like magnesium. Other gas giants like Jupiter and Saturn are mostly composed of gases like helium and hydrogen. Our atmosphere consists of many different gases, mostly nitrogen and oxygen.
Why are states of matter important in understanding space, you ask? Well, states of matter are important because the universe is made up of matter. Auroras, a form of plasma, are affected by the particles coming from space, and the visible universe is made up of 99% of plasma. States of matter make up the atmosphere and space, and they cause different phenomena like supernova, asteroids, comets, and exoplanets, which are all made up of solids, and the galaxy, which is also made up of all three states of matter. Along with that, water acts unusual in space, as it is very cold, so the water molecules lose energy and freeze, turning from a liquid to a solid.
One phenomenon in space is comets. They are balls of leftover rock, ice, and dust from when the solar system was created 4.6 billion years ago. The nucleus of the comets are the frozen part. As these comets orbit near the sun, they start to heat up, and this causes the comet's state of matter to change from solid to gas. The frozen nucleus melts and creates its own atmosphere called a coma. The more gas there is, the bigger the coma gets. The pressure from the sunlight and solar wind can blow the coma dust and gas away from the sun, sometimes in a long, bright tail. Comets have two tails, a dust tail and ion or gas tail. Comets are important because they provide clues as to how the solar system was formed, and there are billions of comets in the solar system.
Pulsars are dense neutron stars the size of a city. They are the leftover debris from a supernova, and a sugar cube-sized bit would weigh about the same as Mount Everest, according to NASA. They look like flickering lights due to two beams of light that are constantly rotating like a lighthouse. The radiation from a pulsar holds information about the structure of neutron stars, and its material is second only to that of black holes in terms of denseness. Under the influence of such high amounts of force, pulsar light reveals the curious way matter behaves inside pulsars, where the nuclei are compressed into the shape of different kinds of pasta, and what is called nuclear pasta. The phenomenon of pulsars and the light they emit are key to learning more about this unique form of matter that is only found inside neutron stars.
On Earth, objects can transfer energy with a push or some type of collision. In space, however, particles transfer energy through invisible structures called supersonic shocks, which are faster than the speed of sound. When particles collide with electric or magnetic fields, they are propelled or boosted forward by energy. If a supersonic flow encounters a stationary object, it forms what is known as a bow shock, not unlike the bow wave that's created at the bow of a boat anchored into a swift stream. One such bow shock is created by the solar wind as it blows into the Earth's magnetic field. Shock waves result when the matter through which the wave is passing through is compressed and the molecules collide and vibrate. When the velocity of the disturbance is extreme, such as in the case of a meteor, electrons are knocked loose and the molecules are ionized. Astrochemistry is the study of different objects in space at a molecular level and how chemical elements are applied in space. This studies an overlap between the tasks of an astronomer and a chemist. It is an astrochemist's job to find out what connection the chemical has to space. The majority of positions have to do with research, and a PhD is required. To work with instruments used to observe, a bachelor's degree in engineering or radiophysics is needed. Being an astrochemist is a good fit for people who are patient, logical thinkers and pay attention to detail.